it's me again, Hannah, and for our final video assignment, we're talking about fermentation. We were all asked to make our own food using the fermentation process, and it just so happens that I love pickles and all pickled things, so I opted for pickling because we can pickle that. Most people, including myself, know what pickles or pickled vegetables are, but few of us understand the microbiology behind the pickling process. So in this lab, I chose to pickle one of my favorite vegetables, green beans, and here they are. Vegetables of all kinds have a finite shelf life, right? Even when they're refrigerated, and all foods are in fact under attack by many kinds of microorganisms. Pickling fermentation not only extends their edible time period, but also enhance and give new flavor to the common vegetables and preserve nutrients. So by using the knowledge of fermentation by anaerobic bacteria, I attempted to ferment green beans by using a non-vinegar pickling recipe that uses salt, water, and natural bacteria from the air, and several types of spices and herbs, which include dill, coriander seed, mustard seed, and garlic and black peppercorns. I added non-iodized salt to distilled water, making approximately a 3% by weight brine solution. I then heated that solution to a slow boil, and after heating for 20 minutes, I poured the solution over the beans and into a pint mason jar right here, which included my spices. Then I screwed on the lid to the jar and let it sit out at room temperature for 3 days, and I kept it isolated from ambient oxygen. The salt I added to the water helped the lactic acid bacteria win the microbial race, if you will. The concentration of brine in the recipe gave a differential advantage to the lactobacillus, especially at the room temperature of 72 degrees, as it outcompeted other microbes that could be harmful. As the lactic acid was produced, the pH was lowered, further inhibiting pathogenic and undesirable organisms. So since lactobacillus are generally considered oxygen-tolerant anaerobes, available oxygen was utilized by the gram-positive lactobacillus, metabolizing sugars provided by the naturally occurring sugars in the beans and by the added sugar. So by glycolysis, glucose was converted to pyruvate and then to acetate. Since this is an oxygen-depleted environment in the jar, the bacteria were primarily converting sugar to pyruvate, then to lactic acid, also generating ATP in the process. Because CO2 is released in this process, carbon dioxide levels increased, and the oxygen levels probably went down slightly until I unscrewed the lid to relieve the carbon dioxide pressure buildup and to taste a bean, of course. And after that, I quickly put the lid back on, and due to the lactic acid, acetic acid, and carbon dioxide being produced, the pH level diminished. I was aware of that as the beans had a less sweet taste and more of a sour taste. The beans turned out a duller green, but were still crisp after 3 days. Pickled vegetables aren't everyone's cup of tea, but I think they turned out great, and I consider it a success. But next time I might change some of the spices and add different kinds of veggies to pickle, or maybe try a vinegar-based pickle. So yeah, that's my fermentation video. Thanks for listening. Enjoy the rest of your day.